In this segment, we're going to go over the small angle formula. The small angle formula is the mathematical formula that relates an object's linear diameter and distance to its angular diameter. Let's first look at an object's linear diameter. The linear diameter is the distance between an object's opposite sides. It is equal to 2r, where r is the radius. So you can look a celestial body's radius in the radius up in the back of the book in the appendices. And then you multiply that by 2 and you'll get the linear diameter. Distance in this case is how far the celestial body is to your eyes. Angular diameter is a measure of the size of an object in the sky. Numerically, angular diameter is equal to the angle in units of degrees between two lines extending from the observer's eyes to opposite edges of the object. So let's say the object we're looking at is the moon. The radius of the moon is equal to half the diameter, and thus the diameter is equal to twice the radius. The distance is how far away your eyes are to the center of that celestial object. That is the distance. You can look in the appendices in your textbook for the linear radius and the distance to certain celestial objects. So remember, the angular diameter is numerically equal to the angle in units of degrees between two lines extending from the observer's eyes to opposite edges of the object. So here they are, two lines extending outwards to opposite edges of the object, and we're looking at the angle between those two lines. That angle is the angular diameter. We would like to solve for the angular diameter given the linear radius of the object and the distance to the object. Now the small angular formula is this equation right here. You have the angular diameter divided by 2.06 times 10 to the 5th, and that's equal to the linear diameter divided by the distance. Now the angular diameter must always be given in units of arc seconds. The symbol is the 2 hash mark. Now the units of linear diameter and distance don't matter so long as they are the same units. So if you're going to express the size of the object as in miles, then the distance must be expressed in miles. If you're going to express the diameter in feet, then the distance must be in feet. So long as the units are the same, it's okay. Now this number, 2.06 times 10 to the 5th, is the conversion of the angle from arc seconds into radians. So long as you give the angular diameter in units of arc seconds, you'll convert nicely. Let's look at an example. Let's say you're given the full moon in the night sky, as shown. The diameter of the full moon is twice the radius, so I labeled it as 2r, and that is 3,476 kilometers. So twice the radius is 3,476 kilometers. The distance to the moon is 384,000 kilometers. We would like to find the angular diameter. Well, we are going to use the small angle formula. So we leave angular diameter in the equation because that's what we want to solve for. And we divide by 2.06 times 10 to the 5th, and then we set that equal to the linear diameter, which is 3,476 kilometers, divided by the distance, which is 384,000 kilometers. Now notice that kept the units the same between distance and diameter. So therefore, units cancel. So let's take 3,476 divide by 384,000. And we get 0.00905208. And notice that there are 6 digits here, and there are 4 digits there. So we would keep these 4 digits and round the 08 up, which would just be 9052. Now to solve for angular diameter, we need to multiply both sides of the equation by 2.06 times 10 to the 5th. So when we multiply both sides of the equation by 2.06 times 10 to the fifth, we notice that the left side 2 cancel out. And the answer you get is 1865, and the units are arc seconds. Let's say we wanted to convert this answer into arc minutes. Well, we know that there are 60 arc seconds in 1 arc minute. So 1865 divided by 60, well, that's 31 arc minutes. Now we see that the units of arc seconds cancel. So 1865 times 1 divided by 60 is 31, and the only unit we're left with is 1, or an arc minute, and so we carry the arc minute down. Let's say we wanted to convert this answer into degrees. Well, we know that there are 60 arc minutes in 1 degree. So 31 times 1 divided by 60, well, that's equal to about a half. And once again, the units of arc minutes cancel, and we're left with the unit of degree. So the angular diameter is 1865 arc seconds, or 31 arc minutes, or a half a degree.